trigonometric function in a unit circle, right? Okay, now we know that a unit circle, a circle with radius of 1. And I know you're familiar with this, correct?
Yes.
Okay, so when we say unit circle, so any point on the circle, if you get the radius will always be 1. Okay, now, if you get the value of this point, we know that the coordinate of this is actually x and y, right?
Yes.
Okay. Now, we know that if it is x and y, in trigonometry, we express the value of our x as our cosine theta, and the value of our y is sine theta. Okay?
Okay.
Can you follow?
Yeah.
Okay. Now, the distance from this point, which is the origin from this side, that is our x, because that is the change of x, correct?
Yep.
And then the distance from this point going to that point, that is our change of y. It means delta y, correct?
Yes.
Okay. Now, knowing that our radius is 1, if we are going to apply the Pythagorean Theorem, okay, so it means that we are going to have x squared, because this is the radius, right?
Yes.
So x squared plus y, you square that, equals to 1 square. And this means that is x squared plus y squared equals to 1. Okay, so that is why you obtain a general equation, which is this one. Can you follow?
Yes.
Okay, so I think it's clear, right?
Yep.
Okay, next. Now, when we talk about unit circle using the radian measure, okay, so Jesseline, the first thing that I will ask you to do is that I will ask you to divide the unit circle in terms of radian measure. So what you will do is that in your paper, you will draw like this. Okay, so that is your unit circle. So from here, this will be your 0, correct? So you divide the circle into how many partitions do you think? Here.
4.
4. So we know that in terms of pi, the whole circle is 2 pi, correct? The circumference is 2 pi, correct?
Yes.
So if we are going to divide the unit circle into 4 regions, then per region will have to have 2 pi all over 4. And that means 2 times pi all over 2 times 2. Cancel what is common, then what is left is pi all over 2. So therefore, this here will be pi all over 2, right?
Yes.
So to determine this side here, then you will have pi all over 2 plus pi all over 2. Okay, kindly add.
2 pi over 4.
2 pi all over
Over
4
4.
or 2 pi all over 2?
Oh, 2 pi all over 2.
2 pi all over 2, because we just copy the common denominator, we add the numerator. Correct? So cancel. Therefore, this is pi. Correct?
Yes.
Next. To get this radian measure, then that becomes pi plus pi all over 2. Kindly add.
3 pi over 2.
Okay, so that means this is 3 pi all over 2. Okay, so 3 pi, we will check 3 pi all over 2 plus pi all over 2. That means 4 pi all over 2, and that is 4 divided by 2, that's 2 pi. So from this point going to that point, we know that that is 2 pi. Correct?
Yes.
Okay. Now, we're done with the partitions of 4. You see, this is 0, pi all over 2, you have pi, and you have 3 pi over 2. Now, you draw a unit circle again. This time, you are going to divide it by 8 partitions. So, meaning to say, you will draw a unit circle. So, you will have to divide it by 8, right? So, you have to know this. What is this? Okay, fill in all until you will reach this portion here. First partition,
Pi over 6.
pi all over 6, and then
Pi all over 4.
pi all over 4, and then
Pi all over 2.
pi all over 2, and then
3 pi all over 4.
3 pi all over 4, and then
11 pi all over 12.
11 pi all over 12. Is that what you mean?
Yes.
And then
Pi.
pi, and then
5 pi all over 4.
5 pi all over 4, and then
17 pi all over 12.
17 pi all over 12, and then
3 pi all over 2.
3 pi all over 2, and then
7 pi all over 4.
7,
7 pi all over 4.
and then
23 pi all over 4.
23 pi all over 4. Okay. So I'll check, yeah.
Okay.
So you will have 2 pi all over, how much is that? Divided by 12, right? So that's
Yeah.
pi all over 6. This is check. So pi all over 6 plus pi all over 6, that means 2 pi all over 6. And that gives us pi all over 3. So this is wrong. This is pi all over 3. Jesseline. Correct?
Yes.
Next. So pi all over 3 plus pi all over 6. The LCD is 6. 6 divided by 3, that's 2 times pi, that's 2 pi. Plus pi, that means 3 pi all over 6. And that is pi all over 2. And this is correct here. Correct?
Yes.
Okay. Now pi all over 2 plus pi all over 6. This is 6. 6 divided by 2 is 3. 3 times pi, 3 pi. Plus pi. Then that gives us 4 pi all over 6. So 2 pi all over 3. This is 2 pi. Wait. This is supposed to be 2 pi all over 3. So this one is incorrect. Can you follow?
Yes.
Okay, next. So 2 pi all over 3 plus pi all over 6, that is 6. So 2 times 2, that's 4 pi. Plus pi, that gives us 5 pi all over 6. So this is wrong. This is 5 pi all over 6. Okay? Can you follow?
Yes.
Next. Okay, so can you add pi plus pi all over 6? Because there's something wrong with here. Okay, so kindly dictate to me. What is this here?
7 pi all over 6.
And then followed by
4 pi all over 3.
4 pi all over 3. And then this one here,
3 pi all over 2.
3 pi. Ano? This is
Oh
already
wait,
3 pi all.
5 pi all over 3.
5 pi all over how much?
3. 3.
And then
11 pi all over 6.
11 pi all over 6. Okay, let's check. So you will have pi all over 6, pi all over 3, 2 pi all over 3, and then followed by 5 pi all over 6. That's correct. 7 pi all over 6, and then 4 pi all over 3. That's right. And then you will have 5 pi all over 3. That's correct. And 11 pi all over 6. Okay, so you were able to do it, right?
Yes.
Okay, now, so Jesseline, without using your calculator, you can actually you can actually get the value of the trigonometric functions. For example, we know that this point here, this is the initial point, correct?
Yes.
Okay. So when we say initial point, we always start with 0 here, right?
Yes.
We know that the first number in the order
1.
1, correct. That is 1 because this is 1 here. Sine 0 is 0. Do you understand?
Yes.
Okay. So if I will ask you, Jesseline, what is cosine pi all over 2? So the answer is 0 because pi all over 2 is here. This one, right?
Yes.
And if I will ask you what is sine pi all over 2, that means that is 1. You try to use your calculator if it's correct. Pi, it's 1, right? If sine pi all over 2, that's 1. So if I will ask you what is cosine cosine pi, what will be the answer even without using your calculator?
0.
Cos 0 or negative 1? Cosine.
Oh, sorry.
Cosine pi, this is pi is here, right? So
Yep.
cosine is negative 1. So what is sine pi?
Sine pi
Is
0.
0. So if I will ask you, okay, Jesseline, what is the value of cosine 3 pi all over 2?
3 pi 0.
0. What is the value of sine pi 3 pi all over 2?
Negative 1.
Negative 1. Now, that is if you are traveling in the unit circle from here going here. Correct? Do you understand?
Yes.
So that means to say that is counterclockwise because clockwise is going that way, right?
Yes.
Okay. Now, if I will ask you, Jesseline, what is the value of cosine negative pi all over 2?
Cosine negative pi.
Cosine negative pi all over 2.
0.
0. Why 0? Because the movement is from here going here. So that means this will become negative pi all over 2. Do you understand? So if I will
Yes.
ask you, what is cosine of negative pi all over 2, then you will give me 0. What is the value of cosine, sine negative pi all over 2? Then that is negative 1. So if I will ask you, what is the value of cosine negative pi? That means negative 1. Because the direction is coming from this point going that way. Do you understand?
Yes.
Okay, so meaning to say if it's positive, it's counterclockwise. If it's negative, it is clockwise direction. Are we clear?
Yes.
So meaning to say, even without your calculator, you can determine the value of the trigonometric function. Do you understand?
Yes.
Okay, now, knowing that, we are going to derive the value of pi all over 4 because it's easier to solve when you know it firsthand. What if you are not allowed to use your calculator? What is the value of this? Hmm? So you might not know, correct, Jesseline?
Yes.
Okay, so what are we going to do? So we will use the Pythagorean theorem applied to the unit circle. Okay, so we will draw an imaginary line. We know that this will be our y, and we know that this will be our x, correct?
Yes.
Okay, and we know that the radius of a unit circle is 1, correct?
Yes.
And if this line here is perpendicular to this line, therefore, we will have a right angle, correct?
Yes.
Okay, now, take note, from this point going to that point, this is a right angle here, correct?
Yeah.
So since we divide it into two partitions, so therefore, we know that this angle here is 45 degrees. Am I right?
Yes.
So if this is 45, 90, so therefore, we know that this is also 45 degrees. And we are dealing with a special right triangle. We call it 45, 45, 90 degrees triangle, and that is an isosceles triangle, right?
Yes.
Okay. So when it is an isosceles triangle, therefore, we know that this side is equal to that side. Are we clear?
Yes.
Okay. Now, so if we know that this side is equal to that side, if x is equals to y, then I can say that x is equals to x. Correct?
Yes.
Okay. Now, if I will use the Pythagorean theorem, this is x squared plus y squared equals to 1. Then I can substitute my y to be my x. So therefore, that becomes x squared plus x squared equals to 1. So I will add, that is 2x squared equals to 1. We divide 2 to both sides. Therefore, x squared is equals to 1 all over 2. So you extract the root. So that means x is equals to square root of 1 all over square root of 2. So we know that square root of 1 is 1, right,
Yes.
Jesseline?
Yep.
But square root of 2, this is not a perfect square. So therefore, we rationalize. You multiply it by square root of 2. So this becomes square root of 2 all over square root of 4. And that means that is square root of 2 all over 2. Okay? Can you follow? Question.
When you put it square root of 2 all over 2, that's a simplified form of square root of 2 over 4.
Yes, because if there is a radical symbol in our denominator, Jesseline, that is not still in its simplest form. So we have to apply what we call rationalization. So since that is a square root, we have to multiply it by a number that is a perfect square. So the perfect square after 1 is 2 times 2, and that is 4, right? That is why I multiply it with square root of 2 here. Correct?
Yes.
So when you multiply this one with square root of 2, it follows you also multiply its square root of 2 in our numerator here. So it means to say 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 will mean square root of 4. And now, you know that square root of 4 is 2. So you don't have a radical symbol in our denominator. Therefore, this is already in its simplest form. So therefore, we can say that the value of cosine pi all over 4 is square root of 2 all over 2. So since x is equals to y, so therefore our y is also square root of 2 all over 2. Okay, you try to use your calculator. You type in cosine pi all over 4. If it if it is square root of 2 all over 2.
It's 0.999906049.
Wait. Kindly tell me how much is that? 0.
0.9999
0.99 and then
99
99 slowly. And then
06.
0.6. Okay, so you divide this. Square root of 2 divided by 2 if it will give you this one.
0.707.
Huh? Jesseline, wait. Square root of 2 divided by 2, that is 0.707, right?
Yes.
Okay. Now, what is cosine of pi all over 4? Cosine. Cosine of
Cosine
pi all over 4. What is the
0.0.9999060498015.
ano? Cosine square root of 2. Cosine, you try cosine. It means to say cosine of square root of 2 all over 2. If it will give us this one.
Yes.
The same, right?
Wait,
Correct?
wait, sir. 923. Then cosine pi. Oh, it's not the same, sir.
It's not the same?
No.
Cosine. Wait.
Cosine
Cosine. Wait.
pi over 4.
Cosine shift pi all over 4 is this one. So cosine of square root of 2 all over 2. Yeah, the same. 0.999. Jesseline, that is
No, it's
0.99984. But if you round that off, that is 0.999, right?
oh, okay.
Correct? Correct,
Yes.
Jesseline?
Yes,
Right?
but the answer, yeah, but it's not, the answer is not exact.
Yeah, it's not exact because that is already in decimal form. Okay?
Okay.
Do you understand? So,
Yep.
if you use the Pythagorean theorem, so meaning to say, here, our value of x is square root of 2. So, what is the opposite of this? This one, right?
Yeah.
So, here, our x is negative square root of 2 all over 2. Our y remains to be square root of 2 all over 2. Okay? That is for
Okay.
3 pi all over 4. Do you understand?
Yes.
Okay. Now, and then we go downward. That is this one, right? The value of x here, 5 pi all over 4 is, what is the value of x? Negative square root of 2 all over 2. And our y is negative square root of 2 all over 2. Correct?
Yes.
We go on the right side, 7 pi all over 4. This means that our x here is square root of 2 all over 2. And then the value of our y is negative square root of 2 all over 2. Okay, copy. That is if the triangle is an isosceles triangle, that is 45, 45, 90 degrees right triangle.
Sir, can you go up, sir? Yes.
So how are we going to do that, Jesseline? So this is pi all over 6. We need to draw an imaginary line. Correct?
Yes.
So it means to say that this is our change in x and this is our change in y. And this is right angle. So since this is divided by 3 partitions here, so this is 90 divided by 3, it means to say that this is 30 degrees here. Correct?
Yes.
So this is 90 plus 30, so 180 minus the sum of this, then this angle here is 60 degrees. Correct?
Yes.
So therefore, you are dealing with a 30, 60, 90 degrees right triangle. Correct?
Yes.
You know that the distance from this point to that point, that is 1. Okay. Now, I want you to research on the special angle theorem on a 30, 60, 90 degrees triangle. What does it says there?
Oh,
What does it says there?
30, 60, 90 degree triangle is another special right triangle. You can use an equilateral triangle to find a relationship between its side lengths.
Okay, so it says there that, excuse me, Theorem 5-8-2, which means to say 30, 60, 90 degrees right triangle theorem. In a 30, 60, 90 degrees triangle, the length of the hypotenuse is two times the length of the shorter leg. Now, you go back to the unit circle. What is the shorter leg there? That is x, right?
Yes.
Okay. So, meaning to say, if our hypotenuse is 1, so since the hypotenuse is twice the length of the shorter leg, so the shorter leg divided by 2. So it means to say 1 divided by 2, that is 1/2. Can you follow?
Yes.
Okay. Now, using the Pythagorean Theorem, you can solve for y. Okay, solve for y there. It will be like this. I'll write. So, we are now in pi all over 6. This one, right? This is our x. This is our y. And we know that this is 1. Correct?
Yes.
Okay. Now, it says there that the hypotenuse is two times the length of the shorter leg, which is your x. So meaning to say, if we know that our hypotenuse is 1, so this is 2 times the value of x, so therefore x is 1/2. So to solve for y using the Pythagorean theorem, that is c squared is equals to x squared plus y squared. We know that c squared is 1. Right. This is square, right?
Yeah.
Can you follow? So this means to
Yes.
say that is 1 equals to 1 all over 4 plus y squared. So y squared is equals to 1 minus 1/4. Oh my God. So
Okay.
what? So what is 1 minus 1/4, Jesseline?
1 minus 1, 4. 3/4.
That is 3/4, right? So y squared, extract the root. So therefore, y is equals to square root of 3 all over square root of 4. And this is square root of 3 all over 2. Because square root of 4 is 2, right?
Yes.
Okay. Uh, so so we continue, but allow me to finalize. So can you see my screen? So which means to
Yes.
say this is, how much is this here? 1/2. And this
One
is
half.
square root of 3 all over 2. Right?
Yes.
Okay. Opposite that will be here, will our x is negative. So negative 1/2. And then our y will be square root of 3 all over 2. So we will just continue with this next meeting. Okay? So have a great
Okay.
day, Jesseline. Bye.
Okay, so to bye, sir. Thank you, sir. Have a
Bye-bye.
nice
You're welcome.